All right, this is the last session of our virtual IoT and Edge days, and some could say that we kept the best for the end. We'll see. In any case, I have the pleasure to welcome Jason Shepard from Zedida. Jason, has joined the Zedida, fairly well. Fairly recently, but is their VP of ecosystem, is heavily involved at LFEdge as their board chair, and previously he's been working at Dell Technologies as the CTO for their IoT and Edge division. So we're excited to have you with us today, Jason, and looking forward to the presentation. For questions, please ask them using the Ask a Question feature. And Jason wants this to be interactive, so I will be interrupting him as needed, to answer the questions as we go.
Dive
So
in.
please feel free.
Yeah, I'm good with heckling, questions, whatever you want to do. No, I definitely appreciate you having me on. And I've been at Zedida for a bit. I've been doing Edge and IoT for quite a while. Started from like blank slate at Dell back in 2014. Helped get a project called EdgeX Foundry started within Linux Foundation, and that's kind of taken off. And I joined Zedida in part because, number one, I really believe in what we're doing, and I wanted to stick working with the community. So EVEOS that we leverage is part of LFEdge as well, and working with Frederick and some of the variety of folks within Eclipse, because I think it's important to start bridging communities, and we think there's a lot of opportunity here. So we'll talk about EVEOS at a high level, and then we'll also talk about recent additions to support Kubernetes. If you've ever tried to deploy Kubernetes on hardware out in the field, you'll know that it's pretty painful. And as we've worked on it, it makes it a lot more simple. I'm in Austin, Texas. This is my studio by night, so I play music for fun. And although I joke when you move to Austin, they just give you all this stuff. Like, hey, take some guitars and some microphones and stuff. Austin's a big music town. So anyway, so a little bit about me. So where we're headed. So obviously, you guys, I don't have to explain, IoT or Edge. I will say that we see bandwidth costs being one of the biggest reasons for Edge. A lot of people talk about latency, and there's some differences that I'll chat about on the next slide. But it's expensive to move data around. We just saw with IOFOG with Google Coral, like doing analytics locally and then sending events, as they were talking about it. So a lot of reasons, but where things are headed is this notion of interconnected ecosystems. How do we get to a true Internet of Things? It's you have to build trust across networks. Imagine if one company owned the internet. We have to start to interconnect with trust. Data confidence. And so a lot of the stuff that I've been working on with a lot of great people in the community and we're very much involved with at Zedida is this notion of trust fabrics. And so there's a project that we're spinning out, this little teaser called Project Elbarium within Linux Foundation. But at the same time, we want to make ties into Eclipse projects. And we're already working with IOTA Foundation, which has a home within Eclipse as well. Really cool video there at that website, and you can kind of learn more about these layering of trust insertion technologies that drive data confidence across heterogeneous networks. Imagine a world where retail and utilities and insurance and businesses and consumers all start to kind of exchange information and balance privacy and value and protect IP, but you have to have trust to do all that. So really cool stuff coming down the pipe, and it would integrate a bunch of different projects. And so stay tuned on that, just something to check out if you're interested. So this is a taxonomy that we had done from LFEdge. It's a pretty good read if you haven't seen it, but the main point on this is, as I'm sure most of you guys know, if you've been working on Edge and IoT, is Edge is a continuum. There's a lot of folks that say industrial edge or AI edge or thin edge, thick edge, near edge, far edge, but the reality is that it's a continuum from very constrained devices up into regional and access data centers, service providers on the right, serving a lot of users, individual devices on the left that are on-prem or in the field. That last mile network is important. So that's one of the delineating factors, what governs this continuum. The last mile network means upstream I'm on a wide area network, downstream on a local network. You will never do latency critical use cases from a local or from a wide area network. Like deploy your airbag over a 5G network. Not going to happen. Doesn't matter how reliable it is. But you would augment with augmented reality, infotainment, cellular to vehicle, alerting cars that are coming to an intersection. Anyway, so that's one we talked through in this. Another one is, are you in a physically secure data center or are you not? When you're not in a data center, and that could even be at the bottom of a cell tower and it's not locked up, someone can walk up to touch that box, whether it's a gateway, server, smartphone, whatever. It's very different in terms of security. And then the last one is, are you able to run abstraction in the form of containers, virtual machines, et cetera, that simplify the support for apps on hardware, or are you not? So that's the delineation between what we're calling the smart device edge and constrained device edge. Once you get to constrained devices, then everything's embedded. You've got kind of custom development for everything. So I just wanted to walk through this real quick, and the paper goes through a lot more, but for the purposes of this conversation, we're talking about kind of the distributed edge, which is hard stop on the left above constrained devices. It's about 512 megs of memory, 2 cores, CPU, any type of CPU, single box, and then bleeding into the fringes of the data center. But what we're not trying to do is go reinvent all the great work that's been done in the data center and OpenShifts and Kubernetes and in general. We're bridging into that. But important to think. So outside of secure data centers, more constrained devices, much higher scale than you would see in centralized locations, et cetera. So that's the context for today. So we'll talk first about EVEOS. So Eve is a project within Linux Foundation's LF Edge umbrella. And like I said, we've been chatting with Eclipse folks around how does it make sense to collaborate, because we think it's really complementary to a lot of the projects that you guys have in the community. So think of Eve as, in a way, like that smart device edge. I mentioned the mobiles, tablets, any kind of client device out there, PCs. Those are solved problems in terms of ecosystem. Today with iOS and Android and Windows, of course. When you talk about edge computing and embedded compute, it is super, super fragmented. Lots of different types of hardware, different types of skill sets, applications, including legacy applications. You can't just drop and go everything cloud native. You need to support a little bit of everything. And so think of EVEOS as being architected as a bare metal foundation to support all of that diversity at the edge. It would run below an IO fog or a Cura, Sparkplug, of course, as a protocol would run above it in the data plane. Think of EVEOS as like the Android of the edge. Do for edge computing what Android did for mobile, which includes not only providing an open foundation, but also helping you develop an ecosystem of hardware and software around that base. And we'll talk more about the architecture, but it's not just Linux. It's very, very opinionated in terms of integrating a variety of different components. And then it's ultimately about the open API, where you take your pick of controller that uses that open API that helps you not only deploy applications, but also manage the hardware below. So most people don't care about security and management. Day one, they care about the app or all the, kind of the cool stuff that Kilton and Farah and folks were showing in the last session. I mean, that's the outcome in the end is, the app that drives the use case. But once people get to the point, it's like, oh, I'm past POC party of few, and you try to deploy in the real world. This is very, very important stuff, given all the diversity out there. So, I mentioned a lot of this already. So it's the sheer diversity of hardware and software and skills, the scale factor. When you look at that edge continuum, it's like tens of public clouds that matter in the long run, highly sensorized, scale out. Trillions of constrained devices over time, and it's an exponential curve in between. So when you get to the distributed edge, you're talking millions, if not billions, over time of different types of hardware, server clusters on a factory floor, out in a retail store, it could be anywhere. And at the distributed edge, as we call it, you have to assume someone's going to walk up to that box and start trying to tamper with it. You have to assume that it has no defined network perimeter. So just very different than traditional data center tools. Similar in principle, but just completely different tool sets required. So, again, think of Eve as the Android of the edge. It's we'll get into the architecture a bit more, but very, very opinionated, supports a variety of different architectures. It's got an embedded hypervisor, so similar to kind of the JVM model, and build an ecosystem around it. And this part's key. So while there's a lot of great efforts out there that are enabling container deployment, and one thing I'll just also make sure it's clear that IOFOG and all the cool things that they're doing there, that's deploying updates for models and whatnot within the IOFOG runtime that can be deployed on all the distributed hardware. EVEOS could help get the IOFOG application runtime out, secure the hardware, help you manage the hardware below. The same thing we're seeing with Azure IoT Edge or Greengrass, or later we'll talk about Kubernetes. There's a lot of great solutions that have in-band management and, of course, the data side, but they don't have a way to get that application out into the field at scale, and that's where Eve comes in, including the security below. So really important that Eve as a project started with a virtualization first approach versus a lot of the projects that are doing cool stuff, but they started with a containers only approach. And everything's moving towards cloud native. Of course, there's an edge native trend. Part of the working group, of course, within Eclipse. I would say edge native edge apps that don't consider the cloud are just legacy on-prem apps. So edge native inherently has a cloud component, but still runs autonomously when it doesn't have connection. So containers are important, but then virtual machines, Eve has a modular hypervisor, so it also supports VMs. That not only helps you run like legacy apps, they could be Windows-based. There's a lot of SCADA systems or HMI or historians, point of sale systems in retail, video management solutions for like the safety and security market, video surveillance. It enables people to use exactly what you've done today, but then have a transition to cloud native development. A lot of people have. I'm using Linux, but I've pre-qualified my stack, monolithic Linux image, and I don't want to change it. And so Eve, because it supports VMs, can also run that on edge hardware, whether it's a gateway, hub router, server cluster, etc. And the VM support helps you run container runtimes, which would be a Kubernetes, Azure IoT Edge, which has modules within. Greengrass has Lambda functions. Any of the different elements that you might see out there. Your choice of guest OS, all the typical benefits. These are similar principles that you would see in the data center, but again, compacted down and built with the right zero trust security model when you're outside, in the field. So, looking at the architecture, just a couple more details. So it's based on Alpine Linux, and there's a lot of reasons, why we chose that as a community. As I mentioned before, it scales down, to roughly 512 megs. That's the footprint, the tax you pay for Eve that greatly simplifies, your how you deal with hardware and applications. We're seeing more and more hardware providers, starting to leverage Eve and even put it on, start putting it on from the factory. It greatly simplifies deployment and management in the field. Any silicon architecture, actually working on RISC-V right now. 2 cores, reason for 2 cores is there's always 2 copies of Eve running at a time. So any updates happen in the B partition, only when successful does it flip over. Otherwise, it keeps running, doing what it's doing. Because, of course, in the field, uptime is of utmost importance. It could even implicate, create safety problems if there's an issue. The hypervisor embedded within is modular. Initially, it was Zen. Now we've got support for KVM. And we've also been working a bit with Intel on the Acorn hypervisor, which is more of a lightweight, good for mixed criticality, because generally Eve comes sort of on boxes right above the process, if you're looking at an industrial environment. But we're seeing this sort of convergence of the OT production environment and IT type things. I mean, not that only OT does one thing and IT does another. We're seeing those blur together. So this notion of soft PLCs running on common infrastructure with data stacks, that's a trend, and technically, Eve could support that in the future with evolvement of things like Acorn, baked in. Because it's bare metal, you can't brick the device in the field like you can with an agent-based solution. So there's another benefit for it being applied right down on the metal. And then last thing, so the zero trust security model, Eve, with controller of choice using the open API. Eve taps into root of trust, so like a TPM. When you bootstrap it, it creates a crypto-based ID from those credentials, so there's no local username and password anymore. You have to do all access through the remote controller, whether it's on-prem or in the cloud. That prevents tampering. One of the ways bad things happen in the field is people just start logging into the box, down in the basement or up on a, in a wind turbine or whatever, and loading software with no record of what happened. And so that's key. You go through role-based access control in the back end. Eve has the ability to shut off individual ports, so you could like turn off all the USB ports or say, hey, you can't use the Ethernet or the serial or whatever. It's got distributed firewall built in through those APIs. You can control this app can only talk to that app on that box. This app can only talk, say through Sparkplug to this, industrial data stack. This app is dedicated to that port. So there's just a lot of lower level functions that we've built into Eve, along with that flexibility for apps and hardware that make it, again, the Android of the edge, like the one, base that really helps you deploy these things at scale with your choice of app stacks on top. Again, chime in if you've gotten any questions as we go, and we'll have some time at the end as well. So just to kind of highlight, I mentioned some of these benefits. It's, Eve is that bare metal approach, which means you have to put it down first. I mean, stick a USB key and load it. That's, I guess, one drawback. But once you have that, then you've got a super robust foundation. There are proprietary solutions, but obviously there's some drawbacks with that. There's some good solutions out there, and then there's also agent-based solutions. And as mentioned, if you have an agent-based solution, if you don't integrate that agent running on top of the OS tightly with the OS and harden the OS itself, it is very likely you could brick the box, and then you're driving trucks out to the middle of nowhere, quite possibly. So Eve effectively integrates the agent and the OS together in a very curated fashion. So, I mentioned some of these as well. So this notion of distributed firewall, I'm able to buy through those APIs in a very granular fashion, govern where data is flowing. This is especially attractive when you look at like layered industrial networks. You've got kind of level 0 and level 1, and then it kind of goes up in the Purdue model. And whether you're all on the OT side of the house in production, or you're punching over to the IT side, maybe getting into ERP or CRM or whatever, or just as well you could be out on a truck or in an oil rig or whatever. This ability to segment where data is flowing through these networks is very important. Eve has that, enables that kind of fundamental zero trust security model, but just as well, we see people deploying apps on top that do things like SD-WAN and network function virtualization, protocol inspection, looking for anomalies through OT protocols or IT or otherwise. So really flexible, and then of course your choice of apps on top, failover between network types, in terms of maybe you're doing satellite failover off a cell or whatnot. Just a lot of benefits, granular benefits that you just don't get with a stock Linux distribution. So update capability. So everything can be updated with Eve. Again, two copies running at one time, so that way you can update one in a separate sense. You're not taking down a system. Literally downtime is the time to reboot. Update any of the guest OSs, individual applications. Roll back any issues. You can do it through the API across lots of different devices. And again, so this, just to make sure it's clear, this is below like what we were talking about with IOFOG in the last session. So this would be kind of manage the hardware below, get those fundamental runtimes out, any combination of apps, legacy apps, and an IOFOG or whatever, and then in band you would use all the tools from those application stacks. And it's also it has an eventual consistency model. This is another important thing to think about when you're deploying edge compute nodes. Data center tools, well established. In the data center, number one, the controller calls the server, says, hey, here's the software you should be running. You'll update to this. And number two is the controller assumes that it's going to have a basically constant connection, fiber connection or otherwise, to that server or the racks of servers in the data center. At the distributed edge, it's completely opposite. You have to have the box phone home through firewalls and NATs and whatnot into the controller, wherever it may be. And you also have to have, you have to assume you're going to lose connection. So it's this eventual consistency model. You set the state in your controller. Whenever the box can phone home, it figures out, okay, I'm supposed to have these things. As long as it has connection, it works to update those in the B partition. If successful, then it flips over to A. And there's also ways to kind of partition out different layers of the updates, because you don't want to be updating massive, file transfers, everything over cellular, because it's just expensive. I think there might be a question.
There's a question, Jason. So Shant is asking, having experience of deploying edge applications with custom OS distributions via tools like Yocto, Buildroot, there's the fact that debugging is extremely hard when working very close to the hardware. It's also very frustrating, obviously. So does EVEOS provide some sense of ease of adoption when working with bare metal edge?
Yeah, no, it's a great question. And that's, one thing I'll say is the moment you pick an operating system for edge, you're wrong to everybody. Everyone's got an opinion.
Yes.
And so the approach with Eve is build this universal foundation that makes it attractive to hardware providers, because having come from Dell, and I work with a lot of hardware providers, trying to pick the magic OS that your customers will appreciate. Everyone wants something different, whether it's Yocto or, you used Ubuntu Core, I want Ubuntu Server, and a lot of good stuff out there, but it's fragmented. The reason why it makes it hard, easier, number one, is because of the curation that helps you tie into the various different components. And number two is that community that's growing around porting Eve to more hardware, including the hardware OEMs themselves. Because it's more of a universal foundation, it supports legacy, it's got all these tools around security that you have to have when you're out there. The ease of adoption is aided by the network effect in the ecosystem. We'll talk about, there's like 30-something boxes today that are known to run within the Eve community. Of course, people can provide commercial support. So it is hard in general. It also depends on the type of hardware. Eve on, it can run anything. If it's x86, it's got I/O virtualization like VTD. It's got 2 cores. Generally speaking, you plug in a USB stick and it'll run. Things like Watchdog Timer or cell drivers, cellular drivers might take a little time or development, but generally it just runs. It's curated in that sense. But you get into some other things like RISC-V that we're working on now. It takes a little more time. But long story short, it's the ecosystem that makes it easier. Not to say there's not an ecosystem around Yocto, but we're seeing more hardware providers adopt because of that universal nature.
Yeah, and I suppose that specifically around RISC-V, that the support is a bit less mature, and then there's more variability in the actual implementations because, the ISA is certainly open, but then people can do whatever they want with it.
Yeah. So RISC is definitely less mature. Intel, or any x86 with I/O virtualization, very mature. ARM, we're growing it. We just got it running on Raspberry Pi, and we've got it in Jetson Nanos and all that kind of stuff. But it's spread versus a proprietary foundation where whoever owns the foundation has to pick up the phone for everything. It greatly simplifies the support and the reducing the pain, because it is painful.
Certainly.
Cool. Okay, so that's kind of a little bit, and we'll jump to the Kubernetes stuff here in a sec. So I won't read all this. We've talked about a lot of this stuff, and you guys will get the slides. But Eve is as much about, obviously you can go to GitHub, get Eve downloaded. It's as much about, like a lot of the projects that we're working on in these communities, it's about the APIs. It's about creating de facto standards around that. And great for application providers above and hardware providers below. Simplify your life, but also comprehend the realities of the real world, including legacy. That's the reason why we've been curating it, growing as a community. So Zadita helps seed the code, but now there's over about 70 unique contributors today. More than half aren't Zadita related. So it's growing. We've seen about a 30% increase year over year on the contributions. So good growth curves. This year, we'll talk about here in a second about Kubernetes. We are looking to enhance the open source controller within Project Eve. There's a basic one today, using the APIs, but everybody wins if we make the more of an Android model for Edge to handle the fragmentation. So we're interested in help on building that out. ARM support, and actually, RISC-V should be on here, but more and more silicon support, simplify those challenges. We're actually talking with, the ARM folks around, some of the great work they're doing on simplifying root of trust support in the ARM ecosystem. That would be part of it. Always looking to optimize the footprint, get it down a little lighter. But part of the reason for the 512 megabyte footprint today is because there's 2 copies running. There's all those extra protections, and we're seeing that generally when you're doing edge compute and on a gateway hub router server. Of course, 2 gigs of memory is common. 4, 8. I mean, Raspberry Pi 3 has 8 these days, so it's not generally a roadblock, and you get all those benefits. And then the other big thing, it's hence why you've been working more and more with the folks in the Eclipse Foundation. You guys have a relationship with CNCF. We've been working with them as well. LF Energy's doing some cool stuff within the Linux Foundation and working on sort of streamlining how people work together in the utilities space. OSU is part of the open group, and we're working there in terms of helping on reference architecture tied into the energy space as well. So yeah, it's really about how can we enable and collaborate with other outside communities. Let me see another question here. So.
Yes, another question from Shant. So can you elaborate in terms of the zero trust security in Eve? Does it include something that has to do with TPM, which are trusted platform modules?
Yeah. So TPM, it goes down to silicon. So root of trust at the base. So Eve taps in there, does works through the credentials within the silicon there. Measured boot, remote attestation. So now I'm proving kind of who I am. I'm running what I'm supposed to be running, and make sure all the keys match and whatnot. Then you get into things like it's kind of the root of trust or zero trust. It's trust no one, always verify. Things like the crypto-based ID, no way to log in locally. Shut down USB ports so that you prevent like a Stuxnet, insider attack with the USB key, if you want. Everything's encrypted in terms of communications. Do full disk encryption. It's zero trust about that layered model. Securely transporting data, doing distributed firewall. If your controller is capable of it, you could visualize where each app by policy is communicating across a distributed network. So those are all the layers of trust security. Now in your controller, of course, you want to have role-based access control and some different protections within the controller, but a lot of the zero trust model is architected into Eve. I can't tell you how many times I've talked to IoT platform folks that say, oh, I communicate over TLS and I have login in the back end. I'm secure, right? It's much deeper than that.
Yes.
Yeah, much deeper than that. And it depends on depth, is the key. But we don't do everything with Eve. It's add-on, protocol inspection, add-on virtual firewalls, extra bells and whistles as apps. Hopefully that answered the question. Definitely chime in again if there's another one.
I think you answered it well in any case.
Okay. Cool. So yeah, so there's a page. You'll get the link. Even market different types of hardware providers. Of course, we like I mentioned, we run on a Pi, so we're legitimate as a open source project. Again, we would welcome collaboration. There's the links in here that you'll get. Okay, so let's talk about Kubernetes. So that was kind of set up just so you understand what Eve is. And as mentioned, it supports architected to support any kind of workload, containers, virtual machines, and virtual machines tend to be really handy for container runtimes, like Kubernetes. I mentioned this, and just to kind of summarize, really cool stuff happening. Of course, Kubernetes born in the cloud, and we're seeing it extend to these thicker edges, or the regional edge, the access edge, all data centers still. Similar in principle, some evolution for kind of managing clusters, in these more distributed data centers. But that paradigm, once you get outside of the data center and you start needing like a robust zero trust security model, you start needing the box to phone home versus the other way around. You have to assume that you're going to lose connection. You've got people that don't know anything about IT that are rolling trucks out to deploy things. That's where the simple API wrapper plus the low footprint, that eventual consistency model, all these different benefits that Eve provides really start to kick in, and they complement, all the work that people are doing in the data center. It's similar principles, necessarily different tools. And so if you look at the way, with Eve, so Zephyr and projects like that, that would be out of scope. Those are for constrained devices. There's a, that's embedded. A lot of projects working in that space. Eve goes down as a foundation, like that bare metal foundation, down to that last point where you just can't, do a containerization or workload abstraction. Technically, it could go lower than the 512 or so that it is today, but all those extra features you add, and it gives you that footprint. But we're always looking to reduce it. But there's a breaking point, around 256 megs of memory, or maybe slightly below that, but certainly won't work in the kilobytes that we see on the far left side. So what's happening is Kubernetes is evolving from the centralized cloud. We're seeing it come down. We've actually been working with the folks at SUSE, Rancher's now part of SUSE, and some others. As they come down, really cool stuff happening. But when they start bleeding out of the data center, then these different diversity things kick in, and the need for zero trust and the need for autonomous operation. And so Eve, the way we're building it, kind of provides that lowest common denominator bare metal foundation. Its relevance drops as you get into centralized data centers. Those are solved problems. But as the Kubernetes paradigm comes down, those stacks, whether it's K3s or K8s or micro K, K8s or K0s, all of those things can start to run on top of Eve and get the best of both worlds, so to speak. Cool. So you look at how does it benefit? A lot of the things on the left are some of the benefits that we've talked about already. Also really important to think about when you do IoT and edge solutions is to separate out the infrastructure plane from the application plane. We've seen hundreds and hundreds of IoT platforms over the past number of years, and clearly we are all here because we understand the value of open source collaboration and help drive de facto standards, as well as stop people from doing undifferentiated heavy lifting. And there's a lot of undifferentiated heavy lifting happening in these spaces. We all benefit from having more consistent infrastructure, and then you differentiate around the wheel in terms of unique hardware and applications and services. But it's also important to, so many of these platforms, they do a little security, a little management, a little bit of analytics, a little bit of whatever. When you do everything, you never do one thing well. And it's also important to separate your infrastructure management, managing the box, managing the app delivery, but not be in the data path, from in this case, cluster management, and then of course there's also data, and apps. It's important to separate it because you're inherently out in the field going to have different types of app stacks. You might have third-party service providers in your organization. You need to have separation of concerns. Rarely are the people that drive a truck out to install an edge node the same people that manage it over time, the network or infrastructure admins, and they're not always the same people that do DevOps, data science. And so having the different infrastructure and app plane, it was important. And I also say, when's the last time your ERP system managed your PCs? You just don't do that, in the IT world. But in IoT, we've seen this kind of blurring of the lines, which doesn't really bode well for scale over time. So, Eve enables that infrastructure management. There is a console invitation. Zadida, we've done an integration, of course, and I don't want to make this about us. This is really about the open source components. But if you want to watch a video, there's a link down below, and it's literally, because of the APIs, you click some buttons and say how many edge boxes do I want in my cluster. Very different clustering at the edge because there's a location affinity. In the cloud, you don't care if it's a rack of servers. You pick resources. You don't really care where they are. At the edge, you need to think about, hey, these 2 boxes I'm creating a cluster with, or 3 boxes on a truck, those are the boxes I need. And so you have to pick those things, click a couple buttons, and go to town. But it could be any distribution, any backend. But yeah. So and then the key point, of course, is that the right foundation for the field. Let's see. I got another question here.
Yeah, it just appeared. So Shant is asking, does such cryptographic bells and whistles in terms of security hamper the performance of the edge devices from the application layer perspective, with an assumption that crypto functions are computationally computationally expensive?
Yeah, no, I mean now I can't say cryptographic. The cryptos things that if you're in the application plane, depending on how you're doing encryption or various different software defined SD-WAN or whatever, that's outside of the scope of Eve. Within Eve, the full disk encryption, things like encrypting the orchestration path, it's very low overhead. Most of the stuff we're talking about is not creating a hit on the applications. There's always a light hit, but it's not that. And then we also pass Eve, because of that, the virtualization first approach, we pass directly from the IO to the applications, IO virtualization. And so you can get a high level of performance there. Some people are using KVM because it tends to provide a little more performance. Other people are using Zen, and then I mentioned Acorn. So long story short is there's not a tax in terms of CPU for the security bells and whistles, so to speak.
And in any case, since you are building on the top, or rather you are a specialized flavor of Linux, then any hardware supported by the Linux OS should be easily integratable. I mean, there are specialized cards for random number generation that help out with cryptography, or even cryptographic coprocessors that you can deploy for specialized applications. So I guess, I mean, it would require some work, but this is something that could be leveraged, right?
Yeah, and that's the thing is, one thing you could do if you have more advanced crypto or encryption thing, or you're doing some sort of ledger technology. I mentioned Alvarium. We're in that working group. We're talking about from a trust insertion standpoint. Every time if you are injecting trust, whether it's through root of trust and then encryption and things like ledger and immutable storage and confidential computing, these layers of technologies bound together with a framework. That's what Alvarium is about. There is a tax at that point for injecting trust. On one hand, if you are driving more trusted data and more business value, it's worth it to pay that tax. We're looking at ways where you can bundle data and you provide trust around that data set, so you're not trying to do it discreetly. And the other thing is that's also, Frederick, you mentioned, is you can offload that stuff to a dedicated coprocessor. And Eve allows you to assign, say you have an app that's doing encryption, you could literally assign that to a couple cores or a GPU or whatever. So we'll see it evolve over time. It's definitely a good question, and there's always that trade-off between footprint and performance and whatnot. But yeah. Okay, so that's kind of the base and the setup around why Eve for as a base for Kubernetes. So yeah, I mean, kind of wrap up, make sure we have some time for if there's any other questions, but we welcome you guys to join in. I mean, Project Eve, obviously open for anyone. We would love, not only from a EVEOS standpoint, and see if there's ways to plug into some of the Eclipse projects, improving the open source reference controller, that's in the project. We're kind of talking about ideas like, would it be interesting to look at, obviously Sparkplug is, more in the data path and around the data modeling and, the MQTT brokers, but, would there be value to look at the telemetry around the infrastructure being able to be broadcast out, through a Sparkplug format? Of course, the benefit of Eve is you could deploy a plugin for Sparkplug, or of course, things like IOFog and Kura and a number of other application stacks. But here's just some thoughts. Let me make sure. I might come back to this.
Yeah, my colleague Hassan provided a question there. So he says it's undoubtedly becoming clear that technology adoption for IoT and edge solutions are on the rise. So away from ecosystem discussion, what advice would you have to industry leaders who are seeking to play a role in this domain?
Yeah, no, good question. So I've been doing this for a while, as I mentioned at the front. First thing I would say is don't build another IoT platform. My God, do we have too many? When you look at to get to value, you need to pick a part of the ecosystem and focus on it. Eventually, even AI models for common tasks, even AI infrastructure becomes part of the open infrastructure. I mean, you look at all the stuff like the TensorFlows and all that. AI models for facial recognition. Is that a car or a bicycle? Color, whatever. That's going to become commodity. And what's going to win long term to play in this space is build necessarily unique hardware or software, offer great services. We're entering into the service economy. The whole point of Alvarium is to get into entirely new business models and experiences. But the last thing you want to do is reinvent the middle. I can't tell you how many startups I've talked to over the years that have basically said, "Oh, I'm so unique. I can ingest data and I can put it into a base database, buffer it, and I can do some analytics, and I do AI, but really it's a rules engine." That's not the valuable part is working on projects like we're doing in Eclipse and Linux Foundation, otherwise to standardize the base so we can add value around the wheel. Look at what happened in the operations world. We went 5 years ago, you got big players that are trying to build data centers and do everything and build their own platforms. And now you're seeing all the operations folks build on the cloud scalers, and they're adding their domain expertise around it. And we're talking about tools like Sparkplug and whatnot to help with data exchange. This is where things headed. All new markets start with everyone coming out swinging, trying to own everything. It's going to be awesome. And then people realize, oh, this is painful. Maybe I should have a go-to dance move, one thing I do really well, and then find some adjacencies. So that's the recommendation I have in terms of approaching the market is make sure that you're not working on a solved problem and not doing undifferentiated heavy lifting.
Yeah, and I think you are perfectly right there, especially since over time anything becomes a commodity. Linux is a case study in that, in the sense that 20 or 30 years ago, people were making good money selling operating systems. And even development tools and all of that, and things like Linux and Eclipse gradually made all of those things commodities. And if you want to innovate and make money, you need to build on that at the top and not reinvent the wheel for all of those lower level components.
Right. And the maker movement, I mean, obviously open source is really, really growing, and open source is the modern way to drive standards. We all know that, I think being here, but it used to be the name of the game is say I'm an industrial player, no secret that people would create all these proprietary protocols that locks you into my stack. And, it's about lock-in, and we had a lot of proprietary, but open always wins in the end for scale. But there's value in having closed ecosystems. It's kind of a choice, but the maker movement is driving it as much as anything, because it used to be if I had a lock-in strategy, I would just buy up my competition and kill them. But now there's so much innovation happening everywhere, and the pace of innovation is ever accelerating. There's not enough money in the world to buy up everybody, so you have to change, and that's why people are starting to move towards open. And it's about building more value. And in this the new world, you win by merit, not lock-in. You offer good stuff, and you win, and you collaborate on the stuff that's not valuable, and that's why we're all here. So. It's interesting stuff. It's been and the other thing too is don't forget the people part. The hardest part with digital transformation is people. It's not technology. That scares me. It's not my job. That makes me do extra work. I don't have the skills. And so in all the things that you do is making sure that you focus on usability, even in security. Security without usability means that people try to hack around it. And that's part of the point with curation of things like Eve and some of the work that we're doing in various projects. So anyway, so that's that. I see another question here.
Shant is back with a question. Since EVEOS is in a way near to hardware and kernel development, I would like your controversial opinion on Rust for hardware drivers, hypervisors, kernel development. Upstream Linux might be rigid, but what about IoT OS distributions? Is that a good fit for Rust?
That one is my Rust knowledge is rusty, I guess. That one's beyond my pay grade. Definitely, we can get back to you, Sean. If you drop me an email at jason@zadita, and I'll we'll talk with some of the developers, or you join in at the LF Edge, the Project Eve working group. But I know we've talked about Rust. I just don't remember some of the benefit or the
Yeah, and the thing is, I'm not a kernel or driver developer myself. When I was writing actively code, I was much more at the business application level, so to speak. But from what I've seen recently, I mean, Linus himself was quite open about incorporating Rust, at least for parts of the kernel, since essentially the memory security it provides and various other benefits made it a good fit in order to reduce, the number of bugs in the kernel and things like that. So I guess in an IoT perspective, that makes it a good fit, at least for some IoT applications as well. And we've seen traction, for example, the Zeno protocol was written previously in OCaml, and they migrated to Rust because of all the benefits it provides. And they get a very, very good throughput and high performance as well there. So I guess we see at least in the Eclipse ecosystem a trend there, and in the Linux kernel community there seems to be some consensus about accepting Rust, but that's all I can say there.
Yeah. I mean, Kathy. So Kathy, I think I mentioned up front is part of Zeta. She's running our new developer program, which I'll highlight next, and she gave Rust a thumbs up. But and there's any good open source project, the best way to vote is with your hands on a keyboard. So just dive in. So the other thing, if you guys are interested, we'd love obviously to collaborate. We're looking at collaborating with several projects and been having conversations. We've launched a new developer program. Obviously, like I mentioned, we want to build up the open source reference controller beyond kind of the basic functions today. But an EVEOS without a controller there's not a lot you can do with it. I mean, you can kind of hack away at the APIs one by one, but just so you guys know, so Zeta is offering a free trial to our cloud, should you want to tinker around. And we're building, Kathy is running this. We're building little developer quick start guides. We started with Kubernetes. You can kind of get bootstrapped and deploy Kubernetes and play around with that. But we want to do the same. Chatting with Kilton about doing one for IOFog, and we have an event later in the summer where we want to feature some stuff. So just kind of a call to action. If you guys are interested, you can email devprogram@Zadita, but Kathy put in her email there, and as well, Kathy@Zadita.com. Send a note. We're in kind of that alpha stage, adding folks, and we wanted to target specific communities, and Eclipse is a priority to kind of help us work through the basics, and also, of course, this is as much about the open source side of things as anything, and then we're going to expand it over time. But if you want to get involved, email Kathy or devprogram@Zadita, and we'll get you set up and kind of grow into it. We'd love to get like IOFog or something into the clicky from the back end. You click a button and it deploys on the hardware, and then you can start doing all the cool stuff with the TPUs and stuff that we were seeing in the last demo. So fast track to deploying stuff out in the field. So
absolutely, that would be interesting.
Yeah, cool. So that's I think that's all I got. If there's any other questions, I appreciate the questions as we go. But any last questions? I know we're kind of coming up on the top of the hour. I'm impressed. You guys have been troopers hanging out. The numbers held steady, and it's getting late over there in Europe.
Yeah, I must say our community is really dedicated, and obviously we've got people from all around the world, and especially in the US as well. But thank you so much, Jason, for the presentation and being around in our community. It's really great to be able to collaborate with the Linux Foundation and see how we can drive innovation in open source together. So thank you
Yep.
so much for that.
Yep. Absolutely. So cool. Well, thank you again for having me on, and drop us a line or stop by the projects. And I know I'm, and Kathy as well. We're coming in to, and joining when we can on the other projects, and let's figure something out.
Yes, absolutely. And that was literally the last session for Virtual IoT and Edge Days 2021. So thank you so much for everyone that stuck towards to the end. We are really happy about how it went, but we can improve. So we will be sending information, a follow-up email with a link to a survey. So please provide feedback about how we can make this event greater for the future. And we have this action button now at the bottom. If you want to fill the survey now while it's fresh, please do so. Our next event at the Eclipse Foundation will be an episode of the Edge of Things series, where essentially we will be discussing the brand new results, the brand new report for our 2021 commercial IoT and Edge adoption survey. So please be there. We'll have a number of Eclipse people and outsiders discussing that, and I will be moderating the conversation. And then don't forget about EclipseCon. So EclipseCon will be virtual again this year, and there's an IoT and Edge track. The CFP is open, and there's still time for early bird till June 1st. So if you want to be among the first to be selected, please submit right away in order to benefit from the early bird selection. Otherwise, you have until June 15 in order to submit your papers. So looking forward to see what kind of great sessions we'll have there. So once again, this was Virtual IoT and Edge Days 2021. Thank you so much. Thank you again, Jason. And looking forward to see you around in our ecosystem.
Yeah, sorry. And I'm like, oh, I've just found it. I'm like, how do I turn off my video? I'm like, I don't need to be here right now. Like, not it. All right, I'm dropping out. But yeah, thank you again.
Of course. So thank you, Jason. All right. So thank you, everyone, and see you around, especially on June 10 for the Edge of Things.